This is Catherine Schmer, and this video is about limits in higher dimensions. So this is assuming that you're familiar with limits of one variable, such as the limit as x goes to a number of f of x. In this video, we're going to talk about the limit of f of xy. So the limit definition for higher dimensions is if the values of f of xy approach L as xy approaches the point x0, y0 along any path, and this is very important, it has to be along any path in the domain of f, then we say that the limit as xy approaches x0, y0 of f of xy equals L. So here's our formal definition of limit, and we want to talk about different properties of limits of functions of two variables. So the following rules hold if L, M, and K are all real numbers, and the limit as xy approaches x0, y0 of f of xy equals L, and the limit as xy approaches x0, y0 of g of xy equals m. So notice these two limits are approaching the same point, but they're limits of different functions, so they can have different results, L and m. So our first rule is the sum rule, and basically what this says is that if you have the limit as xy approaches x0, y0 of f of xy plus g of xy, that's equal to the sum of the two limits. So you can take the limits separately and then add up the results. The difference rule says basically the same thing. The limit of as xy approaches x0, y0 of f of xy minus g of xy equals L minus m. So if you are taking the difference of two functions, take their limits separately and subtract the results. The third one is the constant multiple rule, and that says if you have the limit as xy approaches x0, y0 of k times f of xy, that's equal to k times L for any number k. And remember, L is the limit of f of xy. So you're just taking that constant k and multiplying it by the limit. Rule number 4 is the product rule, and that says that the limit as xy approaches x0, y0 of f of xy times g of xy equals the product of the limits, so L times m. This one is actually going to be very important in terms of rewriting our functions so that we can take limits. Rule number 5 is the quotient rule that says that the limit as xy approaches x0, y0 of f of xy divided by g of xy equals L over m, as long as m is not 0. And the power rule says that the limit as xy approaches x0, y0 of f of xy raised to the nth power is equal to L to the nth power for any positive integer n. So the power has to be a positive integer. But basically, all of these rules are saying you can take the limit of the function first and then apply the division or addition or subtraction or multiplication so that you don't have to do it all as one calculation. And the last rule is the root rule. Limit as xy approaches x0, y0 of the nth root of f of xy equals the nth root of L, which is the same as saying L to the 1 over n, for any positive integer n. And we're also assuming that if n is even, that L is greater than 0, because you can't take the even root of a negative number. So these are your 7 basic properties of limits of functions of two variables, and we'll use these in following videos to actually calculate limits.